AI agents are completely disrupting data engineering. You can think of them as a kid that's completely throwing up all of these carefully created pipelines and models that we have built. And the question is, why? Why are AI agents disrupting data engineering? What's causing this disruption? To me, there is like two reasons. One is who the user is, right? When, as data engineers, for the longest time, who have we been building for? You've been building for software engineers and data scientists. Those are your customers as data engineers, because essentially these people in these roles, software engineers, data scientists, data analysts, etc., they are building applications that use data, right? And they're building these applications that use data. And in order to do that, you need to build pipelines that deliver the data to them. And then you have the end users who are using those applications. So when you're building for software engineers and you're building for people who understand data, you're building it in very specific ways. You're really thinking a lot about the data taxonomy. You're thinking about normalizing the data. You're thinking about making the data as clean as possible to support these different use cases. But what is changing now is that rather than end users using the data through these predetermined or rigid applications, through rigid dashboards that they can slice and dice the data in the ways that the application designer has kind of thought about. You had a product manager who did an interview with the customer and said, these are the three things that the customer wants to do. And therefore, you build an application that solves those three things. Instead, now you have this ability to quote unquote chat with your data. Right? You have this ability to go in and say, ask the question, and then on the back end, somehow the answer gets collected through AI agents. These AI agents might be creating SQL and running the SQL on a database. They may be using a vector database. They might be going ahead and pulling the data by like using semantic similarity. But the point is that rather than us building applications through which data is accessed, the end users, non-technical users, might be directly accessing the data through chat. They might be building like a lovable application that somehow directly accesses the data. And now you're not talking about software engineers with a view of what data needs to look like. So reason number one that AI agents are changing data engineering is that your customer base is different. You are no longer building for software engineers and data scientists. You are now building for non-technical users, business users. And now you need to think about how do you deliver data to business users. The second reason that AI agents are disrupting data engineering is that the center of gravity has shifted. The reason that we all built really large data warehouses and data lakes, and which had a lot of compute, like Matt mentioned the BigQuery, right? The reason BigQuery exists is that you have so much data that you cannot afford to run these things on your little laptop. So instead, you would say, I have my data on my data center is a computer, right? You have this one computer with distributed storage, and you're running all of your workloads on that data center, whether that workload is a SQL workload, whether that workload is an ETL or ELT workload, or whether it is a Spark or a machine learning model. The point is you want to run the compute as close to the data as possible, because the data is so large that you cannot afford to move that data around. So you move the compute to the data. That was the old world. That was the world that we all grew up in. But now the large thing is not the data. The large thing is the model. You now have models with close to 1 trillion parameters. And when you have those huge models, the problem becomes not that you cannot move the data around, but that you cannot run these models that are big and massive on relatively commodity hardware. And so you need to basically say, I'm going to ask the model to do things for me. And the model is basically going ahead and federating all of the actions across wherever the data sits. It is making tool calls to wherever the action happens. So the way I talk about this is that where we used to do compute to the data, now we are using generative AI models to directly convert user intent to the actions that need to happen. And this completely flips the stack, as we will see. So in terms of technology, what happens is that where it used to be that you will build applications that would take advantage of these things that are computing close to the data, right? So you would run a SQL query you run it with Snowflake. Snowflake is running on AWS. It's basically, that's the data lake house. Or you're running on Databricks, and your application may sit wherever it is, but the real meat of the compute on the data happens close to the data. And so a lot of our, as data engineers, what we're doing is that we're building ETL pipelines to take data from disparate sources and land them into this data lakehouse where a lot of the heavy compute was going to happen. But now you basically have a query, which is a prompt that goes into a model, to a generative AI model. And this model basically takes that query. And oftentimes what we say is that we add context to the prompt. And the context is in the form of one or two examples. Where in the old world, you are having compute that ran on millions or 10 million examples, because you're training a machine learning model, you are running it on huge analytics. The large use cases now, the customer use cases now, all involve maybe one or two examples. And those examples, right, then get used for the model, then basically decides what to do. And sometimes that might involve tool calls, that might involve the model itself determining which sources to go get the data from, right? The model is then, this model is becoming a planning and reasoning engine that converts the user intent into action. Okay. And so this becomes a complete change in the way that we approach it, right? So where in the old world, we needed to think about how do we have clean data existing in our data lakehouses? So we were really thinking about tables, and we were thinking about data catalogs to have metadata around all of the data. And we had ETL pipelines that were landing that clean data in that data lakehouse so that our applications could use them. And remember, again, the people writing these applications are software engineers. And so they wanted data that was not repetitive, that was normalized, that they could do the SQL joins. Now, the user, in some sense, is not a human software engineer. It is this AI agent that is determining on the fly what data it needs. And to the extent that humans are involved, it's in figuring out the correct examples to use in our queries. And if that is the case, then everything changes. What changes is AI agents are not as good if you take your data and you explode it across 15 tables and you say, well, you need to go figure out which tables to join to get the right data back. The AI agent is not going to be as good. You might be better off keeping the data in the original context. This is both an opportunity and a huge change, right? So the example I think I like to use is the example of suppose you're doing a loan. You have a principal. What does a principal mean? The principal might be the loan amount. Let's call it the loan amount. The loan amount might be the amount that the person applied for, or it might be the amount that was actually given. Because the lender might say, you asked for like $300,000. I'm only going to give you $200,000. What is the loan amount? It changes, right, depending on the cycle of the loan. And so in the old world, we would have different tables. These tables would have different meanings. We would have them in a different catalog and so on. In the new world, what you might have is a paragraph from the original funding memo, a paragraph from the loan application that basically says, I would like to borrow $300,000, $100,000 in December of 2025, and the remaining $200,000 in December 2026. That description might be the data in context. And an agent works much better with this paragraph than with the exploded normalized data that you're storing in multiple tables. This is a completely different way of thinking about the way you store data, the way you make your data available. This doesn't change the fact that you still need to make the data available, right? You still need to have it somewhere where it's available, but the form in which we have that data available completely changes. Okay? So the other aspect of this is that whenever you're doing a query, it turns out that AI agents have multiple ways to do something, and one way to steer them is to show them an example of what you want, which means that a big part of making AI agents work well is choosing that correct example to provide in the prompt. It's called few-shot learning or in-context learning. And so success with AI agents depends on having these golden data sets, these perfect answers, and being able to pick up what the correct answer is for a specific kind of user request. And so a big part of data engineering is about curation and about creating an example store, which is this new type of data set that we want to start to create rather than the old types of things that we're already used to. So in this sense, then, the old stack was, in some sense, simple. All we needed to know was know what a data lakehouse, right? And you needed to be able to build ETL pipelines and ELT pipelines. The new stack is broader. In addition to this data lakehouse, you need to think about in-context learning that you use to make your agents better. And so, as I said, you need to have an example store, and you need to have a classifier that, depending on the query, chooses the right set of examples for the right type of question that we do. You might need to have a vector database. People call this a RAG, right? And you might need to basically look at queries and find similar matching content, right? So that you might need to do query similarity, that's your compute in a vector database. You might need to do context curation, right? The context as it grows becomes very, very, very large, where as a user continue to interact with your application, as you pull in more and more data in an agentic workflow, and you have to figure out how to compress the context. So the other type of compute that you're doing is context curation as a data engineer. And the type of data that you're dealing with is sitting oftentimes in a graph database. So your stack has become broader. The kind of things that you do in that stack have become broader. And then there's this whole other universe of how do you allow people to curate the data, whether you do it with internal people, whether you do it with companies like Mercor, etc. That is another set of capabilities that you need to start to think about. And so if you think about you're building all of these capabilities, you're building them for AI agents. So how do you make your AI agents ready, right? Ready to be able to use the data. So when you think about your data availability, I will encourage you to think about it in this specific way. Agents do planning, right? They basically do perception and they do actions, right? They perceive, they reason, and they act. The reasoning part is the job of the model provider. It's the OpenAI, Gemini, Anthropic. Mostly their deal, you might give them chain of thought. You might give them, this is the way that I want things done. You might do it with an agentic workflow, right? That is the application developer then building an agentic workflow. So it might be the model provider, it might be the application provider. But as a data engineer, as an ML engineer, I mean, these things are blurring now. Your job is to enable two things: enable perception and enable action. Of the three things that an agent does: perceive, reason, and act. The perception and the action are totally the job of a data engineer or an ML engineer. So in order to basically make perception easy, you need to think about the semantic meaning. How do you preserve the semantic meaning? In my example, keeping the paragraph of the loan amount was a good way to preserve semantic meaning instead of trying to basically break it up and having a very, very normalized structure where it's really hard to get back that semantic meaning. So you want to think about minimal pre-processing of the data, keeping the data in a very context-rich way, right? So that's a change that happens on perception. When you think about actions, actions are tool calls for the agents. So these are, in some sense, APIs. But these APIs now are being called by AI agents, which do not have that much background context on your industry, right? You might assume that you can have an API with specific names and specific variable fields, and people can understand what they are. The AI agent may not, because it doesn't have the context of this industry that you're operating in. Therefore, it becomes even more important to make sure that your tools are discoverable, that they have very clean interfaces, that the documentation is very good, and importantly, that the execution is reliable. Because again, where a human can often look at like a call, say, oh, this failed, and this is how I need to change it. That error correction in the AI agentic, what is called reflection. Reflection is hard. And if you want to make your AI agent reflect and change its behavior, that becomes extremely hard. It's much better to build clean interfaces and reliable execution in the first place. So what I encourage you is that you start to look at your infrastructure, your data availability, your API availability, but look at it from an AI agent's lens. If I were a child, or if I were a new college student, I'm smart, I've learned everything, but I know nothing about your company, I know nothing about your industry, and I look at your API, can I understand how to call it? And if that API call fails, can I look at the error message and figure out how to change the call? That is a good thought exercise to take on everything that you do. So the other thing that you need to think about as a data engineer is that these AI agents throw out a lot of data as well. And you have to think about all of this data that they throw out, right? Whether it is logs, whether it's agent generated output, whether it's intermediate outputs, all of these things need to be versioned, they need to be managed, they need to be put in your data catalog, they need to be available for analysis, and they need to be really stored, because a big part of building agentic workflows is to be able to evaluate how well the agents are doing. And you need all of this intermediate data to do your evaluation. And the reason that you do that again is because all of your observations, your log platform, you need to tie it back to your ML training platform, right? So if for the most part these days, people just do prompts and prompt engineering in the AI engineering space. But usually what you find is that after having released that application out, as you start collecting human feedback, as you start collecting outcome data, you will find the need to improve those agents. And at that point, prompt optimization can only go so far. You might want to do instruction tuning, you might want to do other types of post-training. And at that point, having these agent artifacts available is going to become important. And then the third phase of it is where you might want to do this in a repetitive.